With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our question is, in an experiment of photoelectric effect, light of wavelength 400 nanometers is incident on a metal plate at a rate of 5 watts. The potential of the collector plate is made sufficiently positive with respect to the emitter so that the current reaches the saturation value. Assuming that on the average, 1 out of every 10 to the power 6 photons is able to eject a photoelectron. Okay, we have to find the photocurrent in the circuit. Okay, so what we have been given in the question, the wavelength of the light that is incident on the metal plate is 400 nanometers and at what rate? At a rate of 5 watts. Okay, now we have to find the photocurrent in the circuit. Okay, now photocurrent in the circuit will be, let us suppose I, that is the photocurrent in the circuit, will be given as number of photoelectrons into charge of a photoelectron. Charge of photoelectron. Correct. Now as we know that the charge of a photoelectron is how much? 1.6 into 10 to the power minus 19 coulombs. Correct. Now if we find the number of photoelectrons that are emitted, then we will get the photocurrent. Okay. Now to find the number of photoelectrons, first of all find what will be the energy of one photon. Okay. So the energy of one photon will be energy of one photon will be given by hc upon lambda. Correct. So it will be 1242 divided by 400, this much of electron volts. Okay, now this will be the energy of one photon. Correct. We know that at what rate the energy supplied to the metal plate, so the number of photons will be given as number of photons will be equals to the total energy divided by energy of one photon. Correct. Energy of one photon. Now the total energy is 5 joules per second divided by 1242 into 400. This was in electron volts, so multiply it with 1.6 into 10 to the power minus 19. So this will be the total number of photons. Correct. Now in the question we have been said that we have to assume that 1 out of every 10 to the power 6 photon is able to eject a photoelectron. Correct. So when 10 to the power 6 photon is supplied to the or incident on the metal plate, then only one photon is responsible for ejection of a photoelectron. So what we can say from here is the number of photoelectrons will be equals to number of photoelectrons will be equals to the total number of photons divided by the 10 to the power 6. Correct. So the total number of photon we have calculated as 5 into 400 divided by 1242 into 1.6 into 10 to the power minus 19 into 10 to the power 6. Okay, so this much of photoelectron will be emitted by total number of photons incident on the metal surface. Correct. So what we can say, if we get the total number of photoelectrons, so substitute in this equation. Okay, so what we will get is the photocurrent. Correct. So the photocurrent I will be given as I will be equals to the total number of photoelectrons, that is 5 into 400 divided by 1242 into 1.6 into 10 to the power minus 19 into 10 to the power 6 will be multiplied with the charge of a photoelectron, that is 1.6 into 10 to the power minus 19. Correct. So 1.6 into 10 to the power minus 19 will be get cancelled out. Correct. Now what we will get is 5 into 400 divided by 1242 into 10 to the power 6. Okay, so from here our photocurrent I will come out as how much? 1.6 into 10 to the power minus 6 amperes. Okay, so 1.6 into 10 to the power minus 6 amperes, or what we can say is photocurrent I will be equals to 1.6 microamperes. Okay, so this is our required answer. Thank you.
For class 6 to 12, IIT JEE and NEET level, Trusted by more than 5 crore students. Download Doubtnut App today.